Good morning, everybody. Very nice to be here. I'm Nathan Cunningham. I'm a director in the IDS department. That's Informatics and Digital Solutions here. We also do science. I do science as well. So we're trying to make this relevant. What I'm trying to do with this talk is just give you insight to what our teams are thinking about, how we are trying to understand how to take the big infrastructure footprint that we have here, the 120 petabytes of data that we hold in our data center that we think is going to grow to 200 over the next couple of years, take that forward with the right type of tooling, the right type of approach. So I'm just really here to reflect some of the thoughts that we've been having. And it's key as also that, I'll try and limit the corporate speak. I am a director here. You all know that the real work goes on with my fantastic teams and the ideas which I'm here representing. These are not my ideas. It's my privilege to try and explain them. So, and again, what I wanted to open this talk with really, and when I say Nextflow is key, what Nextflow represents is key. How it represents that as the researchers, as you want to experience the data and actually go ahead and answer really important questions like we've just heard from the previous speaker, that H1, H0 piece. And again, it's that velocity and that speed that you can try and achieve. And to put it in a kind of a clunky metaphor, really, we're in that kind of blockbuster video to Netflix moment with our infrastructure. We have a big video library. You need a lot of stuff around it to play it. It's very good. The quality of the content is fantastic. We've established that. We've done great work over the past 10 years with OpenStack, HPC, and all the rest of it, iRods. But it's how we want to experience it. How do we make that go downstream? How do we support AI, ML loadings? How do we think about big data technologies? And equally important, what we've heard today from Nextflow, how do we get that kind of scalability into different endpoints, the areas where this community represents? It's not just working here within Sanger off the core iRods genomics data, it's where do we take that to? So one of the things that I want to reflect on today is harnessing the power of the hybrid cloud environment. Because reality tells us where, that data center costs 150 million roughly. We're heavily invested over the past 10 years. We have a very, very big capital footprint, and we continue to do so. And that's how our funding is presented to us from the Wellcome, over the QQ, which is around about $500 million. So we have to have a CapEx, capitalized expenditure, with an OpEx. How do we get that cloud expenditure? Right now, we spend roughly about $1 million a year in different public cloud environments. And that's tiny compared to our investments in some respects, but it's how we grow into that. And what does that look like? Where do we put the insight? Where do we put the investments? So that's what I'm trying to do today. Right. So we know we're growing under rapid transformation. Tell me an area of research that isn't across all the fields. Advancements in technology, how we look at some of the 30 kilowatt uploadings, 45 kilowatt, 80 kilowatt loadings, are things that we're investigating now in the data center. The exponential growth in data, in data generation. I think of Matthew's here with the Tree of Life. That's going very well. That will basically be driving petabytes of data towards us as that becomes more and more successful. And that's the same for all the programs here at the Sanger. And then growth of new analytical and methodological approaches. As always, tell me a time when science has never been doing that. We always have been doing that. 10 years ago, I was the director for big data around ESRC. So hubris and enthusiasm, you could say, but actually at the heart of it is an important I/O thing there, like there is with what we saw with Nextflow. Is important about how we get that velocity. What hasn't changed, we've grown the data, we've grown the compute, but how we do the I/O, that's not changed in the same order of magnitude by any means since the 1970s, maybe a 2 or 3 rather than the 18 or 20 that you've seen in the data and the compute. And we need to stay at the forefront of that. So what we currently do at Sanger. So I put this up for 2 reasons, and one was not to wind up my teams, because this is a massive helicopter view, wrong end of the binoculars, okay? But it really just shows you the moving parts. This is basically what we've solved for and how we operate. So you've got our main devices, our at-scale sequencing operations, drives that through into the Sanger, and then we have the pipelines group headed up by David Jackson. In our pipelines teams, and essentially we have the apps and daemons around P4. We kind of got bespoke data. We've got some off-the-shelf stuff in there that puts us into a MySQL type world with LIMS. And there's a lot of things going on here. There's postcode, there's a whole lot of teams, there's massive amounts of, depending where you look into the Sanger, there's 80, maybe 100 FTEs doing some of this activity when it's coming through. There's a huge amount of investment in these areas. So please, this is the Times World Atlas trying to explain an A to Z of Cambridge, okay? So take that health warning with it. Metadata, through to the storage. Again, I've just called it iRods and Luster, not to wind you up, Pete, just to get it down on there, high speed and our general store. I haven't talked about our S3, our Isilon, that's ECS with Dell. We're looking at that and all the rest of it. And then it goes into the compute side, of which we have invested very heavily and successfully produced high quality iRods product out of our OpenStack environment using the HPC posture. And that's from the on-prem. And we then have also, as I said, we're always spending in the cloud, but I'm just giving you the current view. What am I basing the current if I'm doing digital transformation, where we're going? And again, why are we doing it? Well, we all know this. This is just a highlight slide. This is, you could probably chat GPT this, in all honesty. It's pretty generic stuff. So maybe someone could tell me. No, I didn't, right? But I could have, I guess, right? Or bad, even that might have done a better job. So, but basically, we have outdated software. A lot of that stuff is on Perl. It's come out of the start. We put this up 10 years ago. This is just reflecting where we need to go. How do we get that Netflix? How do I decouple the infrastructure more? And I say, how do we get the velocity that we need? Deprecated libraries, and again, reliance on some libraries that are no longer maintained and secure, technical resource gaps, inadequate documentation. Now, you'll see this everywhere, right? And I've put this in. This is not us to really worry and panic about it. I'm trying to call this out honestly about where we are. So we put an investment plan together on the infrastructure, on the teams, on the IT department, so we can scale and solve the right parts of the problems for you, our community that we serve. And it's not us telling you what you need to do. And it's moving it from the computer that says no to the computer that says, yes, we get that, but it needs complex orchestration. And that's basically what the teams invested in the IT department can do for the Sanger and the wider community, and stand up a system that will work to solve the next 10, 20 years worth of questions that this community is asking. So that's where we're coming from, where we're going to. So I want to leverage the strengths of private and public cloud, as you would expect, but it genuinely is a multi-cloud hybrid strategy that we have. I can't emphasize that enough. We have the OpenStack cloud system in now. We want the scalability that brings us. We want the cost effectiveness. One important thing is about where the software resource is sitting and how it's being orchestrated and where it's running. Remember, we have the 120 plus petabytes now growing all the time. We give our data away for free, as you all know. We are in the academic sector, as we all know, and that's entirely right and proper. But it does mean breaking that blockbuster to Netflix dodgy metaphor that I just stood up is we are monetizing this. We have a big video library, but we're giving it away for free. And that's what we want to do. And that's what we invested in to do. So as we know, how do we monetize the product? Well, we don't. That's why we need the capital investments. But how do we get velocity? How do we work well and flexibly going forwards in a cost-effective manner? That's why we need this hybrid. Of course, public cloud is part of our thinking and it's part of our solutions. But again, if you look at the end, that's that flexibility and scale. But the end one then is data security and compliance as well. One really key, I just don't think Vivek's here, but he's one of our first informatic leads to do trusted research environment pieces of work with Queen Mary. That's really important. How do we, as we go forward, start to bring in more of the work, say, that EBI do over the road, some of the more personal sensitive health, kind of Caldecott Guardian type thoughts? Where do we stand that up? And remember the network here, we have a very high speed network to run the scientific loadings. Then it's more of an open, what you'd see in a campus more at university. So again, it's very hard to segregate. So it needs a lot of thinking, and how we achieve that posture is part of this hybrid solution. I just want to call this out. So OpenStack is empowering the hybrid cloud environment, and it does give us that scalability, resource management, flexibility, and security. It's a CapEx investment. We can demonstrate return on investment, and we know how to develop the stack as we go forwards. But we also know, and I've used Nextflow here, and it's excellent, as just so you all know. I do really want to say to you, we understand that this offers you really useful things, just as Conda does, just as any of this kind of some low-code solution might do. and giving this flexibility like Cloud Nebula and all these other things. What I'm trying to get at is why do we want to do this, and how do we work with you to give you what you need? So part of the thinking that we want to establish is, as we look at our investment line, it's not one old block. We've got legacy, so the things that's going to get sunsetted. You've got business as usual, the stack, the thing that we invest in now and it runs now, it's running science now, and the future. So that's the innovation, the dev space. So again, part of our thinking about this is, how do we understand what this is? It does offer some challenges, but it offers a way. You can see I'm trying to call out some of the value here. Where do we take it to? And again, it's like working in that dev environment. Let's give you the environments that you need to test this, but let's not break that kind of core corpus of our iRods type of data. So it's that balance we need to make. So again, took me ages to do. I swapped out that bottom bit to Nextflow. So you can see and I put Cloud VM on the other bit. But really what I'm trying to get at here, guys, is the underpinning infrastructure as a service. What I mean by that behind that open stack HPC, how we operate, that posture we achieve, is that underpinning piece. And it's really important how we layer on top these other things that give you what you need in terms of the velocity, the flexibility, and all the rest of it, and we can achieve that. And we can basically, with Nextflow, with Cloud VM, with partnerships, we can put that on top, but I am emphasizing that hybrid posture here. It's not, we're going to flip into a cloud first. And again, if you want to look at that as a community, Broad has been reflecting on some of their fantastic work they've done with Google and gone into the cloud, but they've also found it very hard to monitorize as they've gone forwards. And again, this is because, again, that core product, nobody's trying to do anything nefarious here. It's just honestly trying to find things, how they scale in environments like this. When you are a genuine big data generator, you are genuinely one of the global big data generators for genomics. That's us. That's what we do. So we have to solve for that. So future state. So synergistic. So these kind of copy each other, these two statements. I've just pulled out different things. So what we want basically is that, what does containerization, Nextflow, complementary technology empower researchers to do? And so this is why I think we're solving, and this is what I want to basically your COI, your enterprise partner, our team, to the ask, to the PI, to the science ask, to the H1, H0 type questions. How do we stand up the right services? Automate and streamline resources, package and share resources effectively, lightweight and portable containers are part of that. Process and analyze large-scale genomics data sets with Nextflow workflows, using Spark, using whatever. What I mean by that is that, how do you get in front of that containerization and start doing that analytic and that insight piece compared to the corpus of all the potential data that we could stand up at you, and the fact that we can't put it all into a container because it's bloody massive and you need a big data center to do it with. And then you need automated software tools and shared resources, so it's easy to share and work with. I've called out GitHub there, but these other things, but GitHub is a useful technology, I believe. And then we feel that, I think if these are pillars of what we're doing, and this is me trying to write kind of an underpinning piece as we might pull this together, accelerate research, let's measure that. Are we actually being useful for you guys? Enhance collaboration, are we giving you tools that makes it easier? So you basically, when FTP is not enough, right? When you have to do other things. Promote reproducibility, and it's really critically important, that research integrity, data reproducibility, absolutely essential as we go forwards, especially as we start thinking, as we might start building out knowledge bases and do some other types of activity. How we are going to articulate our underpinning knowledge, absolutely essential that we can go right down to the base assumptions. And then lastly, because I have to think about this, reduce costs, or maybe pragmatic costing, should be a better way of saying that. It is a hybrid solution. It's that CapEx versus OpEx. Maybe that's again too strong. It's CapEx with OpEx is what I'm trying to articulate, and work out what that balance point is that gives us all that we need. And then lastly, it's that fostering collaboration and accelerating discovery. If we're doing this right, I think that's what the future could look like for us. And I'm just trying to call out with some simple boxes there. Integration of the technologies, that's given us the streamlined containers, and it's given us that kind of speed of what that gives us. The transparency gives us the reproducibility, so what you're doing is trusted. No researcher in this room will move forward without trusting what they're looking at. Being able to publish that into a 4-star journals, obviously, every time. And a hybrid cloud, we have to own that hybrid posture. It's a Sanger thing. It's something that we need for the scale that we're at, but we need to own it and make sure it's working for where we're going. How do we move, just to finish on that dodgy scenario, from that Blockbuster video model to that Netflix model? That's what we're after doing. Thank you.
Thank you very much. Any questions? Have fun.
Thank you. Oh. No, you do. You choose. You choose.
I was chosen over Paolo. Wow. Thanks, Nathan, for that talk. I was wondering, with the hybrid system, with the public and private cloud, does the public cloud like kind of get access to the private system's files, like, you know, data store, or is it like kind of copied over? Is it like a copy of the data is accessible?
It gets right. So we need to mature our data product approach, open, safeguarded, and controlled. Open genuinely means open. It's our open, fair data. You always have access to that, but I'll explain that in a minute. Safeguarded is really protecting the IP of the researchers sitting inside the Sanger. So they want to share, but that's under the researchers' normal working practices. And controlled means controlled. It's either on a posture from personal sensitive variables, MOD type work, highly commercially confident type work. What you'd mean, actually a controlled environment. So no, you won't have access to that unless you're party to it. But to answer your question, what I want is a set of, as we orchestrate that into, say, containers, and we talked about data, how do we think about this? We're trying to get velocity. So we're investigating certain tools. I'll just call out one. This is just one of many. We're thinking of things like Weka and things like this, how we get velocity onto the stack and how we can stand up a set of services that could look about it. What I want is basically the ability to stand up a set of information products which are got less data in them, that are useful for insight. And then if you want the data products, then there will be a matter of writing versions of that, but I want to limit what that means. And what I want is a repository of published versions that have value, just like, say, the Met Office do, just like NASA do for the remote sensed imagery. How you access that? There are cuts of that. And that's what I need that to be, as pragmatic as possible, because that will be the thing that you would be able to access easier. Doesn't mean we can't do other bespoke work, but there's a different chain of work there. But ideally, what I want to get to is a set of information products, the summaries of the data. They have high velocity. They are the things that can be spun around very, very easily. And that's what I'm at. Does that make sense? So that's like you accessing, again, on Met Office. If you want to look at the 70-layer climate model with the Cray £2 billion computer, yeah, you can. You can consume that on the HTML5 looking at the layers on any browser, but you can watch your weather forecast. What do you want to do? Is that all right? That answer?
Yeah, I think so.
So it's yes, but you're not going to get. I'm not going to open that up to everybody because I can't. That doesn't make sense. Yeah.
Somewhat related. How do you manage data in hybrid cloud? I mean that maybe you have local pipeline, you want to scale out into the cloud, the data is local, or you replicate the data. How you manage that?
Okay, so we internally we stand up a set of products. So you've got Pete and Martin here. They're the guys who've architected what we do there. So we have the idea of a farm, and that gives you a set of products that we utilize around a key set of technologies. To get that into the public cloud, we would do a cut of the data and use the tool, the most appropriate tool for where we're going. So we're quite agnostic really about where it goes. So on your talk, we love all that we're saying. The thing that we need to think about the dev is, as you can orchestrate on our S3 onto our ECS or wherever we go, we really have to think about, we'd have to stand up a virtual S3 with the right type of data assets on there, and then that could flow. And it's not that I want to be putting bottlenecks in, it's not that, but it's that primary data source, because what I would prefer, if you wanted to get hold of the corpus of high quality genomic data producing iRods, that we build services to that basically leapfrogs the need for you to use the S3 piece and gives you those tools. So I'm sorry it's a bit of a generic answer. The real answer is you need to talk to Pete offline, and he'll give you the full story about what we actually do. When we work with Biobank, the things that we've done, when we were doing the Heron piece of work for the COVID response, and how we worked as the key instigating institute, is how we responded to that. There was a strong, as you would imagine, obviously in the labs, run by the science, but it's all about the data. How does that get velocity? Where does that land? And we work with an independent company to do that.
Hey, I'd like to know more about the granularity of your hybrid environment, or at least know your thoughts about that. Do you think it's going to be, say, all instruments that have got all their data processed in the cloud versus other instruments got all the data processed in-house? Or no, within one pipeline, like some steps to be on site versus some steps in the cloud, and having no very fine grain ability to jump environments?
It's the latter. The reason is we have to be pragmatic. It's where do the costing comes, the other. So we're solving for data, compute, software, network, and security. That's how we deliver everything, all those postures. And we need to achieve, there's different pathways through that depending on what we're asking. So there's different answers to that. But in terms, what we want to articulate is, say for your program, what is your core data products that you need to drive insight? So we need to call those out and actually invest in those so they're stood up. They don't need regenerating all the time. And we cut versions of those. As say, maybe an instrument changes or some underpinning methodology might nudge it a little bit, or we change basically a library class or our results. Then we decide, do we want to invest in refactoring back through the versions and all that? But that's for the core. We're not going to do that for everything because we'll run out of time and resources, and we've still got other things to do. But in terms of all instruments, we need to have an active stance on all instances. It doesn't mean that we initially invest in all of them at the same time. We need to do it on that golden thread piece, the thing that's got most value. And again, if we think about why do IT projects fail, they're trying to eat the elephant all the time. 70% still do. It's that quick wins, explain the need, get the quick wins, get it working, get the golden threads working. That will build success. But it's really easy to over-engineer. Again, the beauty of why I love working in academia and why I want to be here, it's the variety of things that we asked. It is not a sausage machine, right? There's an underpinning, yes, we need the velocity, we need the data, but they all sit at different endpoints. And we must reflect that on the solutions that we make. And that bespoke tailoring, that support from teams, the embedded support maybe from a data engineer, whatever it might look like, what teams like you've got, that must exist, because otherwise you won't get to those new insights by where the science is leading us. Because again, it might not exist, or it might exist, but it's nothing to do with how we've done it here. Do you know what I mean? So I don't want to be too prescriptive. 60-40 maybe, I don't know what the number is. There's a way of us getting the scale and the cost benefit right, but that flexibility is also critical to success. Does that make sense?
Thanks.
Should we make this the last one so we can move on and let Martin have the rest?
Yeah.
Are you also thinking about making your data available for federated analysis in other platforms? And related to that, are you thinking about implementing standard APIs, thinking of GA4GH, for example?
Absolutely. That standard API is absolutely essential. I want us to reflect on that reference architecture, the stuff you guys are doing, AWS, Azure, Snowflake, what say the happening over in the States. Absolutely essential that we understand what is our implementation architecture against those reference architecture, and that we're easy to work with against those published products, the things that you want to put into the global good, those sustainable goals type questions, those other open and fair data type questions, that we need to make sure that that is being presented to the community with the tooling and the services that it needs for it to fly. Does that